शुरू करें? Good morning, friends. In this era of coronavirus, so long as things are not proper in the country, we cannot have the regular classes. So, to utilize our time, the best thing would be to have the online classes. Today we start the subject Thermodynamics. This subject you must have studied in second year, third or fourth semester. After that, you studied large number of subjects, and now to appear for the gate, you have to revise. The subjects which you studied during third year and fourth year, they are there in your mind, but the subject which you studied during first year and second year now will become little difficult for you to revise. So this would mean lot of concentration is required. And then simultaneously you have to be careful that during the course of the lecture, if anything is not clear, you shouldn't hesitate and you must ask. Now, to start the subject, this word thermodynamics can be split up into two parts, thermo and dynamics. Thermo means everything relating to heat, and dynamics is the study of particles in motion. That means thermodynamics is the study where our fluid particles shall all the times be moving, and we are interested to talk about their heat behavior. Heat is an energy during the course of motion. Heat may be converted to work and vice versa. This would mean thermodynamics is the subject dealing with heat and work. And we'll come across many situations where heat may not be there, but work is involved, as in adiabatic process. Sometimes work is not there, as in case of constant volume process, and heat may be involved. One of them may or may not be there, but if both of them are not there, then it is not the subject of thermodynamics. One of them must be there. Now, to start the subject, this thermodynamics shall be involved in many topics: your reactions, nuclear reactors, ice engines, refrigeration, air conditioning, and so on. And to develop the concept for each thing separately shall become very, very difficult. So we would like to generalize the subject so that we name the chapter, see what is happening there. We'll have very few equations, put our parameters in the equation and get the result. So let us see what is available to us and what are the topics of our interest. Available to us is the universe, the so-called Brahmand. In this Brahmand, in this universe, we have to select the topics of our interest. For example, let this be any region in the space which is occupying some volume and has got some mass of the working substance. I am interested to study about this volume. That means all my concentrations are focused on this matter. So I will be naming it as a system under study. Am I interested for its electrical behavior, magnetic behavior? No. I am interested for the thermodynamic behavior, and hence I shouldn't simply call it as a system, I must call it as a thermodynamic system. These are the boundaries which are distinguishing it, and hence shall be called as the system boundaries. Again, if somebody asks, what are the system boundaries? I will be required to redraw these surfaces, which doesn't look nice. So what should I do? I can put these dotted lines either inside the system or inside the system boundaries or outside the system boundaries, depending upon our convenience. So these dotted lines are nothing but representing the system boundaries. And everything external to the system, they should be called as the surroundings for the system. So that our so-called thermodynamic system plus the surroundings put together shall be called as the universe. That means out of this universe, I am interested to talk about my system, and everything external to the system, they are the surroundings for the system. This will mean all my attentions are focused to study on the thermodynamic system. Now, many times in the PSU interviews, the question asked is, what do you understand by the thermodynamic system? and student finds himself in a very awkward position that he has been using the term system but becomes little difficult to define. And hence, during the course of our studies, we will be preparing for our examination as well as for the interviews. No separate preparation is required for the interviews. Hence, thermodynamic system is defined as any region in space occupying some volume, possessing some mass, upon which all our attentions are focused. That should be called as our system. And then surrounding becomes very simple. Out of the universe, this is our concentration, and everything external to our system shall become the surroundings. I hope this should be all clear. Next, let us see what type of the different systems we will come across, so that we should have very, very simple study, make the subject very, very simple. So this would mean, let us have the classification of thermodynamic systems. We can have three systems, namely a closed system, open system, and isolated system. One may feel from the name itself it is quite clear, the one which is closed. That means the working substance cannot come in, cannot go out. But when in the interview it is asked, whatever you know about the closed system, please try to explain. When this becomes the question, we should be very, very careful about it. For closed system, let us consider a cylinder and piston arrangement. This is the position of the piston. Connecting rod, crankshaft. Crankshaft shall have the rotary movement. In turn, the piston shall have the reciprocating movement. Let some working substance, some gas is present in it. And we are interested to study about this gas. Our procedure should be, first, try to see the thermodynamic system. Our concentrations are focused to study the behavior of this gas. So in this volume, the mass of the gas forms our thermodynamic system. Next we have to mark down the system boundaries. These are the surfaces with which these gas molecules can be separated from the universe. Here it was easy to put down the system boundaries well within the system, because I am not interested to include the piston part. I am interested only for the gas molecules. So these are the system boundaries. And finally, everything external to the system, they are the surroundings for the system. Once I have marked down these three terms, the thermodynamic system, boundaries and surroundings, that means we are clear about our objective. Now I am interested to study. What I have to study in thermodynamics? Relating to heat and work. From the surroundings, by some means, let us supply heat to it. Then what happens? Let us note down our various observations. The first observation will be that this heat energy crosses the boundaries of the system and enters into the system. Heat crosses the system boundaries. Then what happens? A part of the heat gets converted to work, and that work tries to push the piston towards the right hand side. Let us imagine in a certain interval of time piston occupies this position. And now the gas molecules are occupying this volume, and the boundaries got affected. So my second observation shall become that a part of the heat got converted to work, which pushed the piston on the right hand side. So work also crossed the system boundaries. And then I find that system boundaries which were selected earlier do not remain same, they get affected, establishing the new boundaries. That means system boundaries are not fixed. Whereas the mass of the gas within the system has remained the same. Nothing has come in, nothing has gone out. So mass of the gas remains fixed. Very frequently we will be using the term flow. Flow will be considered when between the system and surroundings there is some effect. If there is no effect, then we will say it is non-flow. For example, here nothing from surroundings had come in, nothing from the system had gone to the surroundings, so it was a non-flow process. Hence, this system, which was called as a closed system, may also be called as a non-flow system. And later on, we will be developing an equation for this non-flow process, which shall be called as a non-flow energy equation. And that equation will hold good for all the systems which shall be called as non-flow systems or closed systems. Now, to start the system, I stated that in the interview sometimes it is asked, whatever you know about the closed system, please explain. And a student was feeling where it is closed. Nothing can come in, nothing can go out. But that is not enough. If you draw a diagram, explain these 5 steps, the man who is conducting the interview will feel that you know everything about it. You are very clear. And hence, you will surprise that you will not be asked any further question. Because clarity in one intelligentsia level in one question will indicate that you are excellent. Hence, my dear friends, whatever terms we use, we should be very, very clear about it, and then we should be in a position to explain it fully. Because what we require in the interviews, that we can impress upon the man who is conducting the interview, he should feel that out of the lot I am the best. When you feel that you are the best, you will be able to do the best. And hence, every time be courageous, try to have clarity about all the topics, all the subjects which you will be coming across, whether in mechanical engineering or in chemical engineering. I hope it is all clear. Anybody having any doubt, you can ask. Now let us see the second one, that is the open system. At the petrol pumps, you must have seen a compressor which takes the ambient air, compresses it, and is stored in a receiver. And depending upon the requirement, this high pressure air at the required pressures is being taken by the motorcyclists, cars, trucks, so on and so forth. In the compressor, what we are having is a cylinder and piston arrangement. And then we are having the crankcase in which the crankshaft is housed. Then we are having a cylinder and piston arrangement, connecting rod, crankshaft. And in turn this crankshaft is connected to a motor For small cases, it could be direct coupling, or it could be with the help of a belt, a motor shaft, compressor shaft, pulleys, and then with the help of the belt, the drive is given from the motor shaft to the compressor shaft. Atmospheric air is taken in because of the reciprocating movement of the piston. This air is compressed, and the compressed air is then collected in a receiver. And because of the repeated movement of the piston in the cylinder, lot of friction, due to which heat is generated, and then we are having extended surfaces, the so-called fins, all around the cylinder and cylinder head. So that air is blown over it and heat from within the system is rejected to the surroundings. Now this compressor forms our system. We are interested to check up everything for air well within the cylinder and piston arrangement. So, this compressor forms our thermodynamic system. Now, these are the surfaces with which this system can be distinguished in the universe. So, they form the system boundaries. I have not included the motor part because this is electrical system. We are talking about thermodynamic system. And everything external to the system or the surroundings for the system. Once these three things are marked, that is the system, boundaries and surroundings, we are clear with our objective. Now I have to study the details of this system. The thermodynamic study means everything concerning heat and work. Closed system, I started by interacting with the heat. Now, for this open system, let us start with work. Let us switch on the motor. Shaft rotates. Turn the crankshaft rotates. That means energy has crossed the system boundaries. Work crosses the system boundaries. Crankshaft rotates, connecting rod moves, piston moves up and down. Air from the atmosphere is taken in, is compressed. During the course of frequent compressions, lot amount of heat is being generated, and that heat is crossing boundaries and goes to the surroundings. So my second observation becomes heat crosses the system boundaries. During the course of this heat and work crossing the boundaries, do the boundaries get affected? No. Boundaries remain same. So the third observation becomes system boundaries remain fixed. How about the mass of the air comprising the system? Air was being compressed, collected in the receiver, and depending upon our requirements, we can take this high pressure out with the help of a valve. Say at 7 a.m. in the morning, the technician at the petrol pump has switched on the air compressor. For first half an hour, there is no customer. Air keeps on getting collected in the receiver. Then 2 cars come, they take the air, few motorcycles, then there is a rush, one after the other. So then a truck is there. That means at any state, the amount of air collected in the receiver is not fixed. It keeps on changing depending upon the frequency of the usage. So mass of air is not fixed. Now what type of process it is? Atmospheric air taken from surroundings through a filter into the system, air from the receiver taken out depending upon the requirements. So all the time there is a flow of air between the system and surroundings. Thus it becomes a flow process. And hence this open system could also be called as a flow system. And later on we will be developing an equation which shall be called as the flow energy equation. Thus, this entire subject of thermodynamics will be able to deal mainly with the help of 2 equations, one for the closed system, that is non-flow energy equation, and secondly for the open system, that is flow energy. Now let us try to compare the two systems which we have talked about. In both the systems, heat and work could cross the boundaries of the system. They are the points of similarities. Next 2 points, they are the points of dissimilarities. Earlier system boundaries were not fixed. Mass of air was fixed. Now system boundaries remain fixed where mass of air is not fixed. So these two are the points of dissimilarities. And finally, closed system was non-flow. Open system is a flow process. That is because of their inherent characters. I hope this is also quite simple, provided you understand and logically you write down step after the step. And lastly, the third one, which was called as isolated system. Friends, about half an hour back, what we studied during second year, we were forgetting, and we are trying to revise up the things. Now, you may feel that things are quite simple. You can talk about closed system, open system from the name itself. Now we are talking about the third. This also we should be able to just guess what type of system it should be. From the name, isolated. That means between the system and surroundings there is no effect. System remains unaffected, the surroundings remain unaffected. That is isolated system with respect to the surroundings. What does it mean? Let this be a system having some gas in it. These are the system boundaries. As usual, we try to define these three terms. Then we start thinking about its thermodynamics. That means regarding heat and work. From the surroundings, let us try to supply heat. The system is isolated. That means the boundaries are so rigid that they do not allow the heat to cross the boundaries. By some means, I try to do work on the system. the boundaries are so rigid that they do not allow the work to cross the boundaries. The system boundaries remain fixed. Mass remains fixed. And to start with, I stated that if heat and work both do not come into the picture, that is not the topic of our interest. It is not thermodynamics. There is no process. That means one word substitution for it, that this is a system which remains unaffected by the surroundings. That shall be called as an isolated system. You can imagine that there is a class of 40 students. Out of 40, 10 are very serious, 20 are serious but they are taking the subject very lightly, and remaining 10 feel that we are just seeing how to prepare the subject. They are not serious about it. The 10 serious students are sitting on the front benches and waiting for the teacher to come. Some 2 or 3 students from the second category or third category come and they say, let us cut the class, go out, enjoy a cup of tea. Either the subject is boring or the teacher is boring. And for the fun's sake, they are interested to cut. But these beautiful ideas do not cross the boundaries of the mind of those 10 serious students. Howsoever best arguments you keep on giving, they remain unaffected. That means they are unaffected by the surroundings. So they are isolated. That means they are cut off from the society. The rest of the students keep on talking about them, saying that they are the isolated students of the class. Let us not bother about them. They don't bother for us, we don't bother for them. So they are named as isolated students of the class. So, in our thermodynamics, since heat and work both do not come into the picture, so this is not the topic of our interest, and hence we have named for the sake of naming it, and then we forget about it. So friends, we are having only 2 systems, that is non-flow and flow. Corresponding equations, non-flow energy equation and flow energy equation. We have to analyze the given systems. Now let us see what shall be our methodology to study, to analyze any thermodynamic system. Let this be a system having gas in it. If we are bothered to study the behavior of these molecules comprising the gas and then take the statistical part of it. We'll be calling this as a microscopic view of looking into the thermodynamic system. Whereas, if we don't talk about molecules, talk the system as a whole. Say I have to talk about the pressure. I put a pressure gauge and read the pressure. I will not think about force. I am interested to talk about the temperature. I will put a thermometer and see how all the molecules behave. This we are taking a large scale view and shall be called as the macroscopic view. Pure sciences students, they talk everything in terms of microscopic. Every time talking about molecules. We engineers shall take the large scale view and see the subject from the macroscopic point of view. Very briefly, let us see which one is simple. Engineers always take the simplified approach, and then we will decide which view shall be a better view. Studying about the system shall mean studying about pressure, volume, and temperature. Let us start with pressure. To define pressure, we require force, we require area. Then we should know what is force. Force, rate of change of momentum. Momentum means mass into velocity. This would mean for each molecule we should know the mass and the velocity with which it is moving. Striking with the walls of the container, getting rebounded, so on and so forth. Talking about molecules. This shall be microscopic view. For macroscopic view, we are putting a pressure gauge and reading the pressure without bothering about the molecules. This is macroscopic. Volume. Molecules are considered to be spheres. The volume of the sphere, volume of the molecules, volume of the free paths, so on and so forth. Whereas, from macroscopic point of view, volume is in 3 dimensions. We should measure and get the volume. Temperature. Temperature has to do something with the kinetic energy of the molecules. Molecules moving with higher velocity will exert higher temperature, less velocity, less temperature. Again molecules are coming into the picture. Whereas for temperature, we have to put a thermometer and read the temperature. Every time when we talk of molecules, it is microscopic. When we don't talk of molecules, take the large scale view, take some instrumentations and get the properties, that is macroscopic view, which seems to be a very, very simple view. And hence, we will be studying the subject of thermodynamics from the macroscopic point of view. Wherever some more details are required, some concepts are required, we are to know about the molecule behavior, then we will talk about microscopic view, but only when it is required. Otherwise, most of the time we will be talking from the macroscopic point of view. Now friends, I took the example of pressure, volume and temperature. What are these three terms? They are called as properties of the system. Now if somebody asks, what are properties? How do you define a property? Because simultaneously everything what we are studying about, we should be able to define it. Supposingly I have got a system where pressure is 2 bar occupying a volume of 0.001 cubic meter at a temperature of 300 Kelvin. What I have done? I have defined the numerical values of these three systems so that this system can be fully described. Hence, I will say that properties are nothing but the descriptive characteristics of the system. The characteristics with which the system can be fully described. To classify them, we can have intensive properties and extensive properties. So far I have named three properties: pressure, volume and temperature. Very frequently the other properties which will be coming across may be density, specific volume, now let us have these five properties and try to see intensive and extensive out of them. So first we should know what do we understand by the intensive properties. Intensive properties are those which are independent of mass, and extensive are those which depend upon the mass. Very simple to remember. Intensive starts with In, independent starts with In. So intensive are those which are independent. So that will mean extensive are those which are dependent. To have the better understanding, what I should do, consider a system where these properties are to be talked about. Properties, say pressure. And does it depend upon mass or it is independent? To understand it clearly, what we should do, let this be a system whose mass volume is V. I divide it into 3 compartments. In each one of them, mass is m by 3. Volume is V by 3. Pressure, I am interested to talk about whether the mass is or the mass is m by 3. In this room, mass of air is m, volume occupied is V. I put a barometer, read the pressure, it is P. In each compartment, if I put down the barometer, pressure indicated will be the same. And hence, whether mass is m or mass is m by 3, pressure is P. That means pressure is independent of mass, and hence it is intensive property. Let us talk of volume. Mass is m, volume is V. When mass is m by 3, volume becomes V by 3. That means this volume is depending upon mass, and hence it is extensive property. Mass is m, I put a thermometer and read the temperature T. Now in each compartment, I put down the thermometer, temperature indicated shall be the same. So temperature is independent of mass, and hence it is intensive property. Now let us talk of density. When mass is m, volume is V, the density is m by V. Now, mass is m by 3, volume is V by 3, density shall become m by 3 upon V by 3. So, density becomes independent of mass, because when mass changes by the same proportion, the volume also changes, and thus it is intensive property. And lastly, specific volume. Specific volume is volume per unit mass. And when mass is m by 3, volume becomes V by 3. So, V by 3 by m by 3, which again becomes V by m. So, this is independent of mass, and hence it is intensive property. Now, something very interesting. This V was the total volume. This small v is the specific volume. This volume was depending upon mass, and hence it was intensive property. Sorry, this was extensive property because it was depending upon mass. Mass changes, the volume also changes. Whereas the specific volume has remained the same. Why? This is extensive, this becomes intensive. And the difference between extensive and intensive is depending upon mass or independent of mass. Hence, any extensive property denoted by capital letter when divided by mass becomes intensive property and shall be denoted by small letter. V, extensive property denoted by capital letter, when divided by mass becomes intensive property and is denoted by the corresponding small letter. Later on, we will be studying U, total internal energy, as extensive property, and small u, which shall be U upon m and shall become intensive property. Total enthalpy H is extensive property. Specific enthalpy corresponding small letter shall become intensive property. Capital S, total entropy, extensive property, small s, which is capital S by m, becomes specific entropy and shall be called as intensive property, denoted by the corresponding small letter. I hope it should be all clear.
Rajneesh is asking why pressure was the same in both the cases.
Where you are sitting in your home, in the room, this is the mass of the air in this room. I put a barometer and read the pressure as 758 millimeter of mercury. For a given mass of air, this is the pressure. If in your room you put a partition, mass on each side becomes m by 2. Put one barometer here, put another barometer here. Both the barometers shall be reading the same. So whether the mass is m or the mass is m by 2, that means the mass is independent of, this pressure is independent of mass, and hence has been named as intensive property. In this atmosphere, whether you take the entire atmosphere or you take a part of the atmosphere, pressure is same, and hence pressure is independent of mass. Because you have to take out of the total mass if you change the mass. You have not to add the mass, you have not to remove the mass, you are just putting a partition, so that the effective mass in each partition changes. Does the pressure change or not? You can imagine same way as you put a thermometer in the entire room, or on each side you put a thermometer, you read the same temperature. So temperature also becomes independent of mass. I hope it should be okay.
Yes, sir. Few more students have that doubt is clear. And one student is asking, boundary is the part of system or surrounding, or it is neither part of both?
I am standing in a classroom. This is one entry point. This is another entry point and can be used for exit also. This classroom is my system. These are the surfaces with which this system can be distinguished from the surroundings. That means from this GS array, with the help of these walls, this system can be separated. So this classroom is my academic system. These are the surfaces with which this system can be distinguished from the surroundings. So these are the system boundaries. These lines which I have marked, they are nothing but talking about these surfaces. I could mark them inside or I could mark them outside. That means you should always feel that system boundaries are along with the surfaces of the system. That means these lines are representing these surfaces. And these are the surfaces which are a part of the classroom. That means the system boundaries are part of the system. They are the surfaces with which the system can be distinguished from the surroundings. These are the surroundings. Now if somebody asks what are the boundaries, I'll say boundaries are the surfaces which are distinguishing between our system and surroundings. So these boundaries are also the part of surroundings. They are also the part of system. That means it is a common point between the system and surroundings. I hope it is okay.
Yes, sir, that is clear to him. And Trishanka is asking, in control volume processes, if mass changes, then density should also change. So why density cannot be assumed as an extensive property?
This volume within the system where flow takes place in case of open system called as control volume. When we are talking about the mass of the system, we are talking about the uniformity. It is a homogeneous. For homogeneous, whatever mass coming in, going out, the density shall remain the same. say 10 kg per second coming in, 10 kg per second is going out. It is entering at some pressure, say atmospheric pressure 1 bar, going out at a pressure of 5 bar. For this pressure, we should know the temperature. When pressure got increased, the temperature shall also get increased. And now we have to see masses, their corresponding volumes. And then when you see that there are significant changes, then we will say that density is an extensive property. When we talked about whether it is a intensive or extensive, we were taking a system, in it whatever mass is present, whatever volume is present, we take a part of the mass, part of the volume. We were not considering these flows. So that means we were just talking about the given closed system, developing a concept that when there is a change in the mass of that system, then whether the density varies or not. Every time we were taking the same mass m, then taking the mass m by 2, whether the property changes or not. That is the way of classifying a system. Then when it becomes a flow system, things are different here, things are different here. So to develop the concept, here the temperature varies because of the open system. There we were interested for a given closed system, when mass is m or the mass is m by 2, whether the temperature changes or not. That was the way of classifying. Now altogether you are putting a control volume, that means for open system. For open system, for example, this I took as air, which is a compressible. With a little change in pressure and temperature, the density varies. So, when you are talking of a control volume, then density shall become extensive. When you are talking of a non-flow system, density shall become intensive property. ब्रेक करना
हाँ ऊपर से अनाउंस कर दीजिए Guys, we have a break of 15 minutes, so see you after 15 minutes.